In the second video of lesson 2, we are going to again write a rule for the nth term of some arithmetic sequences. First one has that we're given the 27th term, and we're told that it's equal to 263. We're also told that we have a common difference of 11. We're asked to write a rule for that nth term. Now, if we remember from the previous video, the format for an arithmetic sequence goes something like this. To find the nth term, you take the first term plus n minus 1 times d, the common difference. Usually we simplify that expression, but that's the basic way that it shows up. Now we're asked to write a rule for the nth term for a sequence where we're not given the first term. Instead, we're given the 27th term in that sequence. Here's how I would set that up. I'm going to plug in the things that I know. So I know that the 27th term is 263. So I'm going to take 263 and make that my output. 263 is equal to the first term, which I don't know, plus n. In this case, I do know what n is. N, because we're talking about the 27th term, n is 27. I'll go ahead and put 27 minus 1 times d, the common difference, which I was given. That's 11. So I now have an equation that's got one variable in it, which means I can solve for that one variable. If we take 27 minus 1 and multiply it by 11, you end up with 286. And again, you can type that in your calculator, check it out if you like. So I have the first term plus 286 is equal to 263. Almost there. To solve for a sub 1, the first term, we're going to subtract 286 from both sides. And when I take 263 minus 286, I end up with a first term that is equal to negative 23. So now that I know the first term and I know the common difference, I can write my equation in the correct format. So my answer initially would be this. A sub n is equal to the first term, negative 23, plus n minus 1 times d, the common difference, which again is 11. Then cleaning that expression up, distribute the 11. The 11n minus 11. We've got negative 23 add to that, which means that our final expression for this rule will be to find the nth term, I take 11 times the number of the term minus 34. So 11n minus 34, there would be our rule for that particular sequence. So that's what we do if we're given one specific term and the common difference. The next kind of problem, we're going to be given two terms from the sequence. Excuse me. And we're going to be asked to find a rule for that nth term. Okay. So think about things that we know. We know a term, well, actually know two terms, but what we don't know is the first term or the common difference. So we're going to have to do a little bit of solving to find those two things. There's two ways to think about this. The first way is to kind of work your way backwards. I'll show that one. The other way is to use a system of equations, a system of things that we know match up with each other. I'm going to go with the kind of common sense, think your way through that way first. So here's what I know. I went from 148 to 556, and because this is an arithmetic sequence, I was adding the same thing over and over and over again on my way to get there. So keeping that in mind, we'll draw a little diagram here. We've got the 10th term was 148. And then we're told that the 44th term was 556. So I added something over and over and over again to go from the 10th term to the 44th term, or from 148 to 556. So how much have I added to get there? Well, to figure that out, take 556 minus 148. How far have we gone in that number of terms? Well, let's see that. If I take 556 minus 148, that would be a difference of 408. Okay, so we've gone 408 from here to there. Now I added the same thing over and over again. Well, how many terms have gone by? Well, in that case, find the difference between these two. What is 44 minus 10? How many terms have gone by? Well, it's obviously going to be 34. So that means that if I took 34 steps, so in 34 terms, I increased 408 total. The common difference is how much I increase each term to term. So if we were to take then 408, the total change, divided by 34, the number of terms that we were talking about here, that difference would be equal to 12. There's my common difference. D equals this, which equals 12. Okay, so then I take, going back to my initial problem, I take the first term plus n minus 1 times d, the common difference. All right, I know the common difference is 12. Put a 12 here. We got n minus 1. Now, in this case, I don't know the first term, so I'm going to find the first term by plugging in a value for n. I'm probably going to use this term right here. It's a little bit smaller. So n is 10 for this guy. So I take 10 minus 1 times 12. The first term I don't know. It's okay. The 10th term is 148, so 148 is on the other side of the equal side. Do a little math. 9 times 12 is going to be 108. So I've got the first term plus 108 is equal to 148. A little bit of subtraction, minus 108, minus 108. And that first term must be 40. So then I go back to my initial equation and I plug in the things that I know. I know the first term is 40. That's great. So to write the equation, a sub n is equal to the first term 40 plus n minus 1 times the common difference of 12. Clean it up. Distribute 12n minus 12. Add the 40 to the beginning. So to find the nth term, 40 minus 12, it's 28. So I got 12n plus 28. There would be my rule for that particular sequence given those two terms in the sequence. Got a lot of work, but again, that's sort of a way to think your way through it, working backwards. Now, there is another way with solving a system of equations, but I'm going to do that in a separate video.